All right, we now have 5 different particles in our particles project, and in this video, we're actually going to make a 6th and a 7th particle. So let's start by opening up the particles program. Actually, let's run it and see where we're at. So I'm going to run particles program, and let's remember what all of our particles are, right? I have empty, which is the default, it's just nothing. Metal just kind of sits there. Then I have sand, which falls, water, which kind of sprays on its way down, and then I have ice, which stays on my screen for a bit and then eventually melts into water. I want to show you one more particle here. Well, technically it's going to be 2 particles, but really one more that we're going to be able to click and add to the screen. And that one more particle is dirt. And now you might be wondering, what's so special about dirt? Why do we have to wait this long to make dirt? Well, dirt's not actually going to be that special. Dirt is going to behave actually rather like metal. It's just going to sit there and do nothing. But what's going to be really interesting about dirt is the way that it interacts with other particles on my screen. So let's start this video off by just closing out of what's running. Let's open up particles program and we're going to make the particle dirt. So to start, same process as always. Let me add a constant for this. Let me make this a little smaller. Let's add public static final int dirt equals 5. Once I've added it here, I need to add it into my names array also. So let's say names bracket dirt equals dirt. And of course, I've made this array one longer now. There's 6 things in it, so I have to make the length of this be 6. Let's keep going. Let's make sure we add an if statement here. If we click on the screen and the type is dirt, I need to add dirt. So if particle type equals dirt, then let's say grid row call equals new dirt. And now, of course, this is not going to be very happy with us right now because the dirt class doesn't actually exist. So what do we have to do now? Let's make the dirt class. Let's go over here. And now we've gotten in the habit of duplicating one of our existing classes every time we want to make a new thing. There's one class now in here that actually would be a bad choice to duplicate, and that's ice, because ice, remember, actually has stuff in it. So let's actually duplicate one of the other ones. I'm going to do sand since it's right here, and we're going to call this dirt. Pull it up over here. Let's open up dirt. Remember, 2 things have to change. The first is the constant, and the second is the color. So the constant is, of course, capitals dirt. Now the color, what color is dirt is it's brown, and you could put color.brown in here, but it would be kind of interesting if we could actually choose our own custom color. So here's what I'm going to do for this, which is I'm going to go ahead and open up a browser window. So let's go over to Chrome. And once I'm over here, let's go ahead and actually Google. I'm going to do RGB shades of brown. And the first website that pops up is this HTML color codes and actually tells you a bunch of different shades of the color brown. Now, I'm going to choose a little bit of a lighter brown for this. So I kind of like this copper one, that's pretty nice. Fawn is a little nice. There's actually just light brown, which is kind of good. Or mocha maybe. I'm going to do mocha. And actually, I think it was this column of numbers here that are the RGB values. You can ignore all the ads on the side of my screen. Here's mocha. So it's 150, 121, 105. Let me tell you how to do a custom color. You can go here and do new color and actually just paste those in just like that. So now dirt is actually a custom color, which is this color specific shade of brown that I decided. So I can compile this. And if we go back into particles program, down to the last one step, and how does a dirt particle behave? It actually does nothing. Now, I'm going to leave it out of step for now. Let's just see what this looks like. So I'm going to compile this. And let's go ahead and run it so I can run particles program. And we should be able to now see dirt, right? I can click on it and it's this nice, lovely shade of brown that's actually different than my metal, which is gray, but it will behave the exact same. Now you're thinking, Ms. Holman, why did we add this particle dirt? This is not very exciting. This is just metal in a different color. Did you really do all of this just to show us we could use a different color? No. We're going to make dirt do something kind of cool, which is what should actually happen if I spray water on top of dirt? Well, what happens when you put water on dirt in real life? It turns into mud. And how does mud behave? Mud kind of will trickle slowly down the screen, and mud is going to be a darker color of brown. It's actually going to be a completely separate particle. this is the first time we're making two particles kind of interact with each other in an interesting way. So again, how am I going to create mud? Well, when water is on top of dirt, that dirt will actually turn into mud. So let's first make the mud particle, and then let's kind of figure out how we're going to code that to make it happen. Now, to start, when we're thinking about mud, the reason that mud is going to be interesting here is that you can actually only get mud from making dirt and water interact. So mud is not actually going to have a button over here on the screen. It's only going to happen kind of with that natural reaction that I make happen. So that's going to change a little bit about our process of how we make a new particle. So I'm going to start by going up here, and we're going to make a constant for mud. And now I've been making constants kind of in order this whole time, but this one is actually going to be the first time I'm not going to do that. So I'm going to do this: public static final int mud equals 1000. Now the reason I'm doing this is because we've actually used these constants in a little weird way down here, which is I've used them to index into the array here. But you know what we're not going to need to do for mud is put mud in the array of names. Remember, this is what makes the buttons on my screen. And is mud going to have a button? No, it won't. So once I have this constant here, and again, it doesn't have to be 1000, I can be 100, right? I just have to set it to some big number. Let's scroll down. I'm not going to add it in location clicked, right? Because I don't want to be able to click on the screen and add mud. So now it's a question of what do I need to do in step? How are these going to behave? Let's actually start with dirt, because dirt is actually how we generate mud. So I'm going to do this. Else if particle.getType equals dirt. If I have dirt, then what do I need to do? Dirt does nothing except when water's on top of it. So I need to do this. If, and how do I check the one above me? It's going to be grid row -1 call dot get type equals water. Then we're going to say grid row call equals new mud. Now, hopefully there's kind of a little alarm bell going off in your head. Look here, we did row -1. What do I need to do whenever I do row -1? Well, which row doesn't have one above it is the very top row. So I need to make sure I'm not in the top row. So let's do row bang equals 0 and that. And again, the order there really matters, right? I need to check my bounds before I potentially index out of bounds. So there's the behavior for dirt. And now let's do this. Else if particle.getType equals mud. For now, let's just do water behavior row call. Now that's not exactly what we want to happen. So right now our mud is weirdly going to fall super fast like water does, but this is pretty close to what we want to happen. So let's close out. Uh-oh, it's angry at mud. Oh no, I totally forgot to make the mud class. So let's go over here. Let's do new class, or no, not new class. Let's just duplicate dirt. And let's call this mud. Let's make this constant say mud. And kind of like dirt, could be kind of nice to choose a custom color for this. Now, dirt was kind of this lighter brown color, so I'm going to try to choose a darker brown color, kind of like this chocolate one. That looks nice. So I'm going to copy these numbers for chocolate, 123, 63, and 0, and I'm going to paste them into here, 123, 63, 0. Now I think it should stop being mad at me. There we go. And let's run my particles program. Let's add on a nice kind of glob of dirt in the middle. There we go. And then let's put some water on it. And you can see there's my mud. There it is, right? Now, there's one thing I don't really love about that, which is what we talked about. We knew that this was going to be the case, which is mud actually falls down my screen super, super fast, right? How does mud actually move in the real world? Like if you see like a mudslide, it's actually not that fast. It's a little bit slow moving, right? It definitely should not be moving as fast as water. Now, your first instinct might be, well, what if we just went ahead and just kind of stuck a pause before this, like pause 10. We've used pauses before in graphics programs to actually slow down the behavior of the program. And this is the right idea, but it's not quite the thing you want to do. The problem with pause is that it won't just pause for the one mud particle you're trying to step. This will actually pause your entire program. So I think that's not exactly what we want to do. But we can do something else, which is this. So I'm going to type this and then I'm going to explain it. If math.random is less than 0.01, then we're going to do water behavior. If you think about the way that this works, every single time I step a mud particle, what's going to happen? Well, 1% of those times, it's going to try to move like water. And won't that actually have the behavior of slowing it down, right? If it only moves 1% of the time, that should be kind of significantly slower than what's happening right now. So let's see what that looks like. And this might be a little bit too slow. We'll see. We might need to kind of adjust that number. Let's kind of add some dirt on the screen, and I'll put some water on top. And there's our mud. It's trickling down, probably a little too slow. It's pretty slow, but it's kind of nice. And you can see it really reuses the same behavior that water has, but I was able to change the speed pretty easily using this math.random. So what was the point of mud? Well, now we have a particle that is only able to be accessed by interacting two other particles together. And this is something that you might want to do when you're making more particles in this program by yourself. It can make for lots of fun and interesting interactions between the things in your program, which is pretty cool.